So coefficient, you have two hydrogens that each hydrogen has one electron. Here you have, even though the number 1 we would not include that, but we know that there's one electron in each hydrogen, so we have two hydrogen atoms. Okay? Maybe? Conservation of matter. A chemical reaction cannot change the number of each type of atom, just how they are combined to form particles. In this case, there are two hydrogen atoms on each side of the equation. On the left side, there are two particles with one hydrogen atom in each. On the right side, there is one particle, but each particle has two hydrogen atoms. These particles and the number of particles are different, but the number of hydrogen atoms is the same. This is super, super important. Conservation of matter. A chemical reaction cannot create or destroy matter. This changes it from one thing to another. Nor can it change one type of atom into another. A chemical reaction just changes how atoms are combined, changing one set of particles. So it takes this set of atoms, this chemical reaction happens, and it just rearranges those atoms. They don't go away, they just may change the way they behave, or the way they look, or the way they exist. So the number of each type of atoms has to be the same before and after. Again, this is extremely important when we start balancing chemical equations. Whatever amount you start with, you have to end with. Let me check my number here. 94, I may have gone, nope, to 105. Okay, we're getting close. The mass of each atom is also unaffected by a chemical reaction. The mass does not change. Since the mass and the number of each type of atom is unchanged, the total mass of the atoms before and after is the same. If we start with 4.2 grams, we're going to end with 4.2 grams. This is conservation of mass. There are a number of ways to draw molecules. They are not meant to be accurate pictures, just ways to imagine what's happening. All the images on the following pages will be used to show molecules. This is a ball and stick drawing of two hydrogens. So you can imagine here's one hydrogen atom, here's one hydrogen atom, they're bonded together. This is the chemical bond. It's sharing electrons, so what's that bond called? If they're sharing, what's it called? It's called a covalent bond if they're sharing electrons. H2 molecule, it just shows two molecules like bumped up together. This image shows where the two electrons are most likely found in H2. This is called a space-filling model. And then, while this is a schematic drawing showing the chemical bond as the two shared electrons. So if you can imagine it, here is your protons, here's your two electrons that both molecules are sharing. All three of those pictures are meant to show the same thing. Hydrogen atoms are blank found alone in nature. Often, sometimes, almost never. I need help. Roger, what do you think? A? I don't think so. What do you think, Hires? C, I agree. Almost never. Hydrogen molecules are comprised of how many atoms? What do you think on that one, Dakota? 1, 2, 3, 4. I need help. Say it again, I just can't hear.
2.
Correct. Molecules are formed by ionic, metallic, covalent, any. I need help. What do you think on this one, Wyatt Grant? You need help?
Yeah.
Who can help him? Shelby, can you help him out? Say it louder. Any of the above? Nope. When they are shared, they form molecules, and those are only covalent bonds. Chemical bonds that result from sharing electrons. Well, hopefully everybody should know this one now. So I just said that out loud. Michaela, what do you think? I literally just said the answer 30 seconds ago. Say again? I can't hear you. Loud. C. She did not increase her volume one time. Yes, that is correct. During a chemical reaction, the number of any type of atom, like hydrogen, may be lowered, will be unchanged, may increase, may be lowered or increased. What do you think on this one, Isabel Gibbs? Can't hear? C? What do you think, Michael? It is B. It will not change. During a chemical reaction, the number of particles may be lowered, will be unchanged, may be increased, may be lowered or increased. Let's see, Connor, what do you think on this one?
C.
Is it C? D, may be lowered or increased. Remember we said they can change the order. We can get more of them, we can get less of them, but the total has to stay the same. The total number of atoms doesn't change.
This is the last page.
Last one, thank you. During a chemical reaction, the mass of the chemicals before and after the reaction. I think this is what you were thinking, Connor. May be lowered, will be unchanged, may increase, may be lowered or increased. Now what do you think?
C.
C. No? Doesn't change. The mass does not change. Okay, we are done for today.